Hello wonderful person, this is Anton, and well, today we're just going to discuss this absolutely incredible image recently released by the team behind the Hubble Space Telescope that features something that looks absolutely majestic. And the thing is, this is not AI, not CGI, this is really what this object looks like. This is a brand new image of an object referred to as an Egg Nebula, officially known as CRL 2688, and this is approximately 3,000 light years away from us in the constellation of Cygnus. But this is not just a pretty picture, even though this is a pretty picture, because here this is also a really important part of the evolution for many different stars, including our Sun. As a matter of fact, this right here shows us what a lot of stars like our Sun eventually start becoming in the last few thousands of years of their existence. And so in this video, we're essentially going to discuss exactly what this represents and what this shows us, but also how this compares to a lot of other similar nebula, and what all of this tells us about the evolution of stars, and to some extent, the evolution of the galaxy itself. But first, let's start with the name, and of course, with what exactly this is. Technically, this is an object referred to as a protoplanetary nebula, kind of similar to one of these objects, many of which have also been captured by Hubble, and many of which represent an extremely brief transitionary stage in the lifetime of many different stars that in this case only usually lasts just a few thousand years. And eventually this will become what's known as a planetary nebula. An object that you might be more familiar with because we've recently discussed one of these discoveries in one of the videos in the description. And so in essence, this is the end of a star very similar to our Sun. Although here once again I would have to address the name. The protoplanetary nebula and planetary nebula actually have nothing to do with planets. This is a very unfortunate misnomer from a few hundred years ago, when early astronomers looking at these objects thought that these objects looked like gas giant planets through their much smaller and less powerful telescopes, and because of this, the name kind of stuck. But in reality, all of these objects are a transition stage from being a star to being a white dwarf. Or to be more exact, from being a giant expanded star that starts to emit and release a lot of gas from its surface and eventually exposes an extremely hot core in the center that transitions into a white dwarf over several thousand years. And it's really that extremely powerful radiation coming from the star or from this white dwarf that then illuminates all of this gas and starts to create these gorgeous formations. But for that initial stage, the pre-planetary nebula, that's actually the stage that we know very little about, and that's the stage that the scientists are trying to understand the most. And so the protoplanetary nebula stage is usually extremely short, and so catching one in action is very valuable for science. And so this particular stage is very mysterious. It's basically the stage when the star finally stops being a star and relatively rapidly loses all of its outer shell, with the white dwarf in the center becoming more apparent and starting to eliminate this gas with more and more energy. And here's one of the more well-known such objects, the Boomerang Nebula. But here's a slightly different one referred to as the Red Rectangle Nebula, mostly because it resembles a red rectangle. But today we're discussing this. And the most important thing about this image is that this is not just one single snapshot, because here NASA decided to combine snapshots from a lot of previous observations, including a much older image from 1997, which was actually the first time this object was observed with so much detail. But it was the 2003 observation that made this object look very, very strange. It essentially exposed these unusual layers we're going to discuss in a few seconds. And so in this case, researchers decided to combine many of these images in order to compare them and to see how things changed. And specifically, they wanted to see how some of these dusty shells evolved in the last decade, and mostly to test various models and various propositions about stellar outbursts, but to also compare predictions about gas motion in outer space with a lot of these visual observations. Now, since this image has only been released now, we don't really have any details yet, but because this is such a beautiful image, we obviously had to discuss it. But what exactly are we seeing here? Well, there are several major structures. First, the obvious one is of course the distinct bipolar jets, which kind of resemble some kind of a searchlight beam. You can actually see them a little bit better in some of the older images. And so here these are very thin regions at the poles of the very thin dust disk, where the light from the star escapes because it contains these holes. And as the light escapes, it creates these twin beams that do resemble a searchlight illuminating surrounding gas. So basically, I guess imagine some kind of a pancake with two holes in the middle, and right in the middle of those holes, there's something very, very bright. And it's this bright object that produces these bipolar beams. But this object is, of course, that star. It's known as V1610 Cygnii. And unfortunately, because of this perspective, we cannot see it directly. It's basically covered by that pancake, buried inside the very thick dust produced by the disk around the star. But here the question is, okay, but why does it have this disk? Normally we expect these disks to exist in objects that have not become stars yet, but this was a star and it's basically transitioning into a white dwarf. And to astronomers, this is a telltale sign that this is a binary system. Here the main star is shedding its outer layers, but a smaller companion star orbiting nearby very likely pulls a lot of this material into a somewhat flat, rotating plane. And so in other words, as the companion spins around the larger object, it seems to produce this somewhat bizarre and somewhat thick, dust-like formation. Naturally, something very similar has been seen in other images, with at least one object known as LL Pegasi even showing this from a completely different perspective. Here you see this from the top. And so in this case, instead of dust expanding in a perfect sphere, like in some kind of a balloon, it seems to get flattened into a dense equatorial disk, in some sense similar to how I guess a pizza chef would spin a dough into a flat object, creating a circle. Or at least that's the explanation for now. But then we also have these concentric arcs that are particularly visible in this older image, that create these almost perfectly spaced rings or ripples. And in this case, this is very likely the result of various spluttering events, or basically pulses coming from the star when it occasionally poofs up and releases a lot of material, which it continuously keeps doing for hundreds and hundreds of years. And this is what usually happens to a lot of these aging stars as they become red giants and start to emit a lot of their outer layers by continuously poofing up over and over. But once again, the way that some of this moves and some of the shapes this forms suggests some kind of a hidden companion. It would be very difficult to explain this if this was just a single star. But to once again understand why this object is so important, let's briefly discuss a kind of a timeline of a typical star, including of course once again our Sun. And so first, for billions of years, in the case of the Sun approximately 10 billion years, the stars continuously burn hydrogen. But as the hydrogen runs out and helium accumulates, they eventually start to transition into the red giant stage, which usually happens when the star exhausts most of its fuel and starts to swell up. Here's actually a really good timeline showing us how a star like our Sun is going to transition and how it's going to eventually become this red giant. And then we have something known as late asymptotic branch stage. Quite a mouthful, but in essence this is when the star begins to lose its outer layers as it slowly transitions from the much colder red stage into a much hotter blue stage. And that's basically because the white dwarf in the middle slowly starts to become more visible. And so here this stage possibly lasts for a few hundred years, as a lot of these layers accumulate and create a bunch of shells around the star. That's actually what you're seeing here. These shells were basically formed during this late asymptotic giant branch stage. And following this stage we get the protoplanetary phase. This is when the star in the middle starts to become hotter and hotter, mostly because the layers around it start to disappear. And that's when it starts to illuminate all of this gas, eventually resulting in a very beautiful formation visible from pretty far away. But for this particular nebula, for the Egg, this star is not that hot yet. It's only about 900 Kelvin hotter than the Sun, so it's not hot enough yet to ionize the gas or to basically make it glow on its own. So essentially it's not doing this yet. And so instead we only see the nebula because this dust is reflecting the starlight directly. This is not ionized gas yet. And after a few hundred years, it's going to transform and basically become one of these planetary nebula, kind of like the famous butterfly that we discussed not so long ago. This usually happens when the star reaches a temperature of at least 30,000 Kelvin. And so for the Egg Nebula, it should happen in the next few hundreds of years. And so at this point it starts to emit a lot of UV radiation, which ionizes all of the gas around it, making it glow very similar to a massive neon sign. Okay, cool. But I think it's also worth comparing this to some of the other famous nebula, just to see how it's probably going to look like in about 1,000 years. And well, this is one of the youngest ones known to us. The Stingray Nebula. As a matter of fact, it might have only turned on back in the 1980s, so it's only like 40 years old or so. Although surprisingly, it also doesn't seem to be extremely powerful, because for some reason it's already fading, with many ions already recombining. So actually this particular nebula is a little bit mysterious. Then we have the much more famous Cat's Eye Nebula, that's known to be one of the most mature planetary nebula, and essentially shows us what most of them are supposed to develop. Here, the central star is approximately 80,000 Kelvin, and it's also creating a lot of powerful winds with a lot of material moving at 1900 km per second. As a matter of fact, because it's moving so fast, it even created this very strange inner bubble that's slowly expanding over time. Then the previously mentioned Butterfly Nebula, NGC 6302, is actually one of the hottest in terms of temperature. Here the star is close to about 250,000 Kelvin and seems to represent a much more violent stage when it comes to mass loss, which is also why it looks so spectacular. And then we have the iconic Helix Nebula, the Eye of God. We've actually recently discussed this because scientists have also discovered something really strange in the center, but this is also an object that's pretty mature and has been expanding for approximately 10,000 years. As a matter of fact, this is a single star, so there's a very high chance this is what the Sun is going to look like as well. And so here this is a prototype for a typical planetary nebula. But the thing is, when it comes to these objects, depending on the internal architecture and depending on their age, they do actually look very different and very often create extremely different shapes. But in the last few years, one of the most exciting discoveries was actually this. This doesn't really have a proper name yet, but it's known as IFAS X G055226.2. And the reason this is actually exciting is because it seems to be the oldest planetary nebula we've ever seen. In other words, it's the opposite of this. This is the endgame. And right now it's estimated to be about 70,000 years old. So this is one of the oldest, if not the oldest, ever found. But it's also extremely difficult to see it, so it was actually discovered completely by accident. But because it's so old, it very likely is going to disappear completely in the next 1,000 years or so. Although normally most planetary nebula vanish in about 30,000 years, and so the fact that this one survived for 70,000 years suggests that it seems to have formed in some really specific environment, very likely inside a star cluster that seems to protect it from a lot of galactic winds. But that's basically how many of these objects usually end, eventually disappearing and leaving just that white dwarf behind. But for the Egg Nebula, it's just the beginning. As a matter of fact, it just started to release a lot of these heavy elements into the rest of the galaxy, and so this one is going to be transforming and changing for at least another 20 to 30,000 years. And this is maybe one of the main reasons these are so important. They do end up enriching the galaxy with a lot of these elements, many of which eventually get recycled and create new planets and new stars. And so the dust you see in this image is actually the same type of material that 4.5 billion years ago coalesced to form Earth and to one day form you and me. And that means that by studying nebulae like this, we're essentially trying to understand this galactic recycling system, or the process that creates a lot of building blocks for a lot of future planets. But if we ignore all the science, even without all of this, this is still an absolutely incredible image. And in the age of AI imagery and a lot of CGI stuff, this is just remarkable. It just reminds you that the universe can always surprise us even more. But anyway, we'll discuss planetary nebula in some of the future videos. Until then, check out previous videos in the description. Thank you for watching, subscribe, come back tomorrow to learn something else. Support the channel on Patreon where you can find additional videos, videos without any ads and can DM me directly, or by joining the channel membership that grants you early access. You can also support this channel by buying the Wonderful Person t-shirt in the description below. Stay wonderful, I'll see you tomorrow, and as always, bye bye.